In this video, we're going to talk about how to find the integral of e raised to the square root x dx. So how can we do it? Well, first, we need to start with u-substitution. We're going to make u equal to the square root of x. And the square root of x is basically x raised to the 1/2. So now we'll need to find du used in the power rule. So it's going to be 1/2 x, and then 1/2 minus 1 is negative 1/2. So we can rewrite that as 1 over 2 x to the positive 1/2, or simply the square root of x. Now we need to get dx by itself. So let's multiply both sides by 2 square root x. On the left side, we're going to have this. On the right side, these two will cancel. And so we're just going to have dx on the right side. So let's replace the square root of x with the u variable, since they're equal to each other. And let's replace dx with 2 square root x du. So this is going to be the integral of e to the u times 2 square root x du. Now we can replace the square root of x with u again. So this is going to be e to the u times 2u du. And so I'm going to move the constant to the front. So I have 2 integral u e to the u du. Now let's just get rid of this to make more space. And let's rewrite this expression since we're going to use it later. So now what we need to do in order to integrate this expression is that we need to use integration by parts. So we're going to use the formula integral u dv is equal to u times v minus the integral of v to u. Now I don't want to use the u variable twice. So I'm going to use different letters with the same equation. So let's say u is a and v is b. So we have this formula. The integral of a db is a times b minus the integral of b dA. So let's say that u is equal to a. And so the other part is going to be db. So db is going to be e to the u times du. So we have a is equal to u, that's in red, and then in blue, db is equal to e to the u du. Now, if we integrate both sides of this expression, the integral of db is b, and the integral of e to the u du is just e to the u. Now we need to differentiate this equation. So dA is simply going to be equal to du. So now we're ready to use that formula. And keep in mind there's a 2 in front of the integral. So this part right here, the integral of u e to the u du, that's going to be a times b, where a is u and b is e to the u, minus the integral of b dA. So b is e to the u, and dA is just du. So now we can get rid of this stuff, and we don't need this anymore. Now let's distribute the 2. So this is all equal to 2 u e to the u minus 2 integral e to the u du. And we know what the integral of e to the u is. It's going to be e to the u plus c. So this is going to be 2u e to the u minus 2 times e to the u, and then plus c. You don't have to say 2c because that's still going to be a constant, so we'll just write plus c. Now the last thing that we need to do is replace the u variable with the square root of x into this expression. So here's the final answer. Let me write the original problem. So the integral of e square root x dx is going to be, everywhere you see a u variable, replace it with the square root of x. So this is going to be 2 square root x e to the square root x minus 2 e square root x plus c. And that is the final answer. So that's how you could find the integral of e to the square root x dx.